So hello guys, today I'm gonna discuss with you about the PID. So this one would be the introduction to the course. So the first question is that why PID in the first place? Why not other algorithm and so on and so forth? Okay, so I have few main reasons that why people are supposed to consider PID. The first reason is that the PID is everywhere. It is widely used, especially in automation. All the servo motors, they use PID for their algorithm to control the motors. Okay, in robotics, all is PID as well. So hydraulics, everything that you see, for example, even temperature controllers, all they use PID. Most of them they use PID for controlling the stuff. So it is very well adopted in the industry. The second reason is that it is very easy to understand. So there are better algorithms than PID, to be honest with you. Okay. So for example, something like, for example, adaptive control, or for example, optimal control, those. Okay. So but for those you need, for example, system modeling. System modeling is not easy. It is error prone and somebody expert to have to tune it. But something like a PID, okay, anybody can tune the PID. You don't need a university degree to tune the PID. Even your technician in a factory can tune the PID. So this is the reason that it is one of the easiest control algorithm that you can see, and it is that make it cheap because cost of labor is high, right? PID can be used very cheaply because anybody can tune it, and it is very easy to use and very easy to maintain. As said earlier, many algorithms they need system modeling. So what is a system modeling? It means that you have to have some idea what is the system it is. Okay, it means that you cannot to treat the system as a black box. So you have to draw equations and mechanical, those kind of things. So you cannot to treat the system as a black box. But in a PID, it doesn't matter. Okay, in PID you treat everything as a black box, and you consider that everything is, for example, anything. For example, PID can tune anything. Okay. System modeling, it is not easy, and you need an expert to do the system modeling for you. Okay, so this is the reason, another reason for why PID is very popular. Okay? And lastly, it is good enough for the job. Okay, so it is robust. Okay, so even that if you tune the thing well, okay, it doesn't misbehave after, for example, 1 year or 2 years or 3 years or 10 years from now. Okay, most of the times. So any control system, wear and tear and those kind of things can goes wrong. Okay? The thing that it is that it is robust. It is really robust. Okay, and you can get a very good result for it. Okay, maybe you cannot to get, for example, you cannot to get 100% effective system, but you can get with it 95%. So in most of the times, and that is good enough. So because it's a very cheap algorithm, it is not computationally expensive, and anybody can tune it. Okay, 95% efficiency is more than enough for most applications. So this is another reason why that people they love PID.